For this week's lab, we'll be doing a simulation of the VUmeter using LabVIEW. So a VUmeter is basically an envelope detector for audio signals, and these are the formulas that we will be using. So let's first start off with creating a two for loops on the block diagram. By right-clicking on the N icon, you can create a constant. So for the internal loop, we have a constant of 10, and for the outer loop, we have a constant of 300. So this will constitute to 3000 output values for the VUmeter. So as for the rest, you can look at your lab sheet and put in the components accordingly. Next, we'll create a simulated signal by right-clicking under Express, Input, select Simulate Signal, and place it on your block diagram. When this window pops up, we will change the frequency to 1000 Hz and sample per seconds to 20,000. We can refer to the top right-hand corner and change the parameters accordingly. Once we are done with the simulated signal, we'll move on to create a dynamic data. So right-click and under Search, type in dynamic data. What this does is to convert the dynamic data type to numeric, boolean, waveform, and array data types for the use of other VIs and functions. So when this window pops up, we can choose any 1D array and click OK. We'll move on to the front panel to create the array. So you can click on Search and type in Array and just select this one that you see, drag it to the front panel. So what you need to do is to actually place a number indicator into the array itself. So to expand the array, just drag it downwards. And then next we'll create a waveform graph and place it on the front panel. You can also change the limits of the X and Y axis by double clicking it. And to change the decimal points for the x-axis, right click on the graph and under Properties, go to the display format and change the digits to 2. So with that, you'll continue to work on the block diagram. I'd just like to highlight the connection for this part. So we are missing our build array. So right click under Array, select Build Array and drag it to your block diagram. So we'll just extend one more out. Okay, it's very important to know what you're inputting to your array and then outputting to your array too. So we'll just go on to right click on this build array, select concatenate inputs. If you do not do that, you'll realize that at the end of this connection, you are unable to run your VI. So what I like to do is to first connect the wires of the outer loop first, and then from the outer for loop, connect it into the inner for loop to the build array. So yeah, just do the connection to the feedback node, and from here to the array, and here. So you're pretty much done for this part. As for here, you still see a broken wire. It's because you have to change this auto index tuner of the tuner mode to last value. So here you have a good to go running VI. Once everything is done, you can run the VI, and this is the waveform that you're supposed to see. So take a screenshot and explain your findings in a weekly logbook. You may also like to explore alternative designs to achieve the same objective as above by using the shift register instead of the feedback loop, or use a while loop instead of a for loop. So with that, we have ended our lab session for today.